Swayam Prabha. Digital India. Educated India.
Good morning. Welcome back to the lecture on 3D scanning, and we are in laboratory demonstration. We had discussed about the ARTEC 3D space spider scanner in the previous lecture. It was a blue light scanner. In this lecture, we will discuss about Dr. Pizza scanner, which is a scanner that is enclosed in a cabinet just for the reason that it has a red light which is harmful for the human. So, that was a portable scanner. In that, object can move, the scanner can move anywhere. This is a tabletop scanner that is kept in the lab only. This is Pizza LPX 600 model scanner. The scanner cannot move anywhere. Whatever we need to scan, we have to keep it inside the scanner and scan will take place. It is a red light scanner with these specifications. This is LPX 600 model. The table size is 254. The maximum scanning area for plane scanning is the width is 254 mm and height is 406. So, for rotary scanning, the diameter is again same and height is same. We have two kinds of scanning, plane and rotary. In plane scanning, the table is fixed. In rotary scanning, the table also rotates. We can select these options from the software when we will work on that. Dr. Pixar software is also supplied by the same vendor. So, repeat accuracy is plus minus 0.05. For plane scanning, which direction, this is scanning pitch, which direction for plane scanning given 0.2 to 254 mm, high direction 0.2 to 406 mm. For rotary scanning, circumferential pitch is 0.18 to 3.6 degree, high direction is this. This pitch is actually resolution that I mentioned in the previous lecture. So, this also needs some soaking time. So, these are the specifications. The wavelength of laser is 645 to 660 nanometer, maximum output is less than 390 microwatts. The sensor is non-contact lens sensor, spot beam triangulation method is used here. The triangulation reverse engineering method is used, which is the principle of working out this scanner. So, table rotation speed is 9 rpm, all these specifications are here. So, the important specifications are the interface is USB, we can get the data in USB as well, and power consumption is only 20 degree and the temperature at which it works is 10 to 40 degrees. The other specifications, you can see these. So, the soaking time in the case of handheld scanner was the temperature for the laser to get heated and get excited. The soaking time in this case is differentiation of the different orientations, because the camera is moving in vertical direction and also the table has to be moved, it akin to homing that is there in CNC machines. So, this differentiation it calibrates or it just check all the dimensions, whether it can go up to 406 millimeter height or whether the whole scanning can happen up to 254 millimeter. So, this is that happens in the time. Next is we have a blue button here. This is the button that is there here in the scanner. When we will switch this on, you can observe these are the specifications or the indications from the button. When the button is dark, that means there is no light, the machine is off, the power is off. When it is lit blue, this is red, this is blue. When this is blue, that means, and it is flashing 2 at a time, that is initialization is in progress. The equipment is getting started only. So, that is initialization. So, when it has initialized, the scanning happens, the scanning is in progress, it is flashing 1 at a time and it is lit blue. When it is lit blue and the movement light is dark, this is the movement of light. So, movement of light, if it is dark, then scanning is possible, that because it is ready for scanning. Okay. This is starting, this is operating, the scanning is happening. And if the lit or flashing light is blue and red light is also there and the movement is dark, that means some error is there. So, this is the different status that can have. It as flashing 2 at a time, move clockwise. So, that means initialization, it is flashing 1 at a time, 1 at a time, this is 1 at a time is flashing, this is 2 lights are flashing here, this is 1, this is second. If this is 1 is flashing, 2 is flashing means it is initialization, 1 is flashing means it is scanning and it is moving clockwise. So, when we will start this machine, we will observe these indications. So, this is the inside of the scanner, this is the tabletop, this is tabletop, this is rotary table. So, the camera is fixed here, camera is fixed here. This is a receiver in the inside, we will try to zoom it and show it to you. That is receiver. This camera and receiver are at 45-degree angle. So, there are certain specifications. The optimum angle between the camera and the receiver is 45 degrees. So, what happens in there? This is the slicing way, like as said in CMM we have different slices. We had 4 contact points for the circle, then we took our probe at a little height and have another 4 points. So, this is in the similar way we have different slices, there is no raster, there is no overlapping. So, it all depends at what is the pitch, that what is the distance between the 2 heights that we are giving, or in the circumference also there is some degree when we are talking about the rotary object. When we are talking about linear object, we are just talking about the distances, height and length. What is the pitch between them? It all depends upon that, but these are different slices, like different pages are aligned and those are then brought together to a solid object. So, this is what happens here. So, you can see in the zoomed view, this is the camera, this is camera, and at the farther end we have receiver here. This is camera that we have here. Receiver is at the farther end. Here we have receiver, this is camera, they are fixed at 45-degree now. So, with the exact angle or the perfect angle is 45-degree here, but yes, we can have different angles, but the angle cannot be less than 20 degrees as is mentioned in the manual here. It is not okay if the angle between the receiver and the camera is less than 20 degrees. Also, as you have seen the rotary table, the object shouldn't go outside of the volume. This is not okay. This is 406 mm. This is not okay. It will just scan up till this level. So, above this level it will not scan. This thing it will not scan. So, any object that protrudes beyond the table and height is higher than the specified maximum height, it cannot be scanned. An area where laser beam strikes at a shallow angle can also not be scanned. The minimum angle that it can scan is 20 degrees. Also, the object cannot be a fabric, okay, no fluffy. it is mentioned here actually. The fabrics and objects that have rough nap cannot be scanned. An object that has comparatively smooth surface is suitable for scanning. So, this is okay, this is not okay, this is a smooth surface, this can be scanned, this cannot be scanned because it would not reflect the light back to the receiver. The certain other tips, the objects may be difficult to scan because of the type of material it is made of, because of its color and other qualities. This is a transparent object, this cannot be scanned. The objects that are clear or transparent cannot be scanned. The objects that do not let the light to pass through them can be scanned, those are okay. And also dark color objects, like this is a black object, again the similar thing that I have mentioned in the previous lecture. This is black color and that would absorb the light, so this cannot be scanned. So, if there is a dark color, that again has to be applied with the developer as we saw in the previous demonstration. So, this cannot be scanned, black color cannot be scanned, and bright color objects can be scanned. So, dark color objects cannot be. Black and blue also is mentioned by the vendor. So, glossy or shiny objects cannot be scanned. As you can see, this is a glossy, as we had aluminum in the previous presentation. So, these cannot be scanned. So, these are certain cases where we need to apply some code or some primer code, some developer to scan. In all these three cases, we can apply developer. Right. So, this is the dummy, this is a toy of crow, this is not the actual crow, because this is a red light that would be harmful if it come into contact with any living being, humans or animals. So, that is why it is a closed chamber scanning. So, these are certain tips or certain restrictions to the scanning. So, this is the object that we are going to scan here. This is a holy figure. So, this is this is the model of a holy figure, and this is all in white color. So, this can be scanned easily. We need to apply any code or developer here. We will just put it in the center of the work table and try to scan this. Let us put it here and we will just try to put it at the exact center of the table. Now the camera would put the light and receiver would receive the light back, and it will try to scan. Let us close the door of this chamber. So, the door is closed. Even you can observe that the door color is blue, because blue will cancel to some extent the harmful effect of red light. So, that is there. So, when we switch it on, the initialization happens. This is initialization, the two lights here. If you can see, everything is moving here. So, this is preparation of this the machine, and homing is happening. This is rotating, complete rotation of 360 degree has happened. The camera is moving up and down. Some light is coming on here and getting left back. It is checking everything to make sure that the machine would work properly. This is initialization. In initialization, the start button was blinking with two lights on. So, now we have put the scanner object inside the scanner, and we have come back to our computer interface. Here we have Dr. Pizza software. This is the shortcut for that. So, we will click on this. So, this is the software that help to scan the object. We click there and this interface is opened. So, this option, there is a big button here, scan, green button. We will click this button. When we click this button, it asks for certain options, rotary and plane scanning. Rotary is when we choose this This can scan objects that are nearly spherical to or cylindrical and have smooth curves with little changes. Plane scanning is the scanning when we have few limitations related to the shape of the object. So, normally you choose this scanning method. So, our object in this case is not a rectilinear or the plane object. So, we will choose the circumferential option or rotary option. So, here also it is showing the pitch. This is rotary or plane. So, for rotary it is asking the pitch here, the circumferential pitch and height direction pitch. Then height pitch is at what spaces is the slices in the height on the vertical direction placed. So, that is first we can have 1 mm, then 1.2 mm, then 1.4 mm, 0.2 would be the pitch there. So, this is the kind of resolution that we saw in the previous lecture. So, this is given 0.9 here as default pitch. So, the circumferential pitch is actually given in degrees, not in mm. It is 0.9 degrees. So, circumference rotation is 0.9 degree per scan data, and the camera is going up and down. That is controlled by this, that is 1.0 mm is the pitch, 1 after 1 it can do 2. So, it will have all the slices at 1 mm distances. So, the maximum distance that it can scan here is 406.4 mm, it is mentioned here. So, we are changing the pitch here, 3.2 is the pitch. They were just changing the pitch randomly just to show you how the pitch is changed. We can increase or decrease the value of pitch here in mm and in degrees or divisions in circumferential. It is 0.36 degrees. We can increasing it into the 0.18, 0.44, 0.90. It is just changing in this way. The resolution for circumferential pitch is 0.18 degrees. 0.18 is the minimum value that we can put in, and for the height it is 0.2. Sometimes we are not sure about what is the height of the object, we cannot have this height. So, what we can do, we can preview, the preview button is here, we can preview, because 406 is the maximum height that it can scan, and we need not to scan the whole height, but that will only consume more time. So, we can have preview to see the maximum height that we need to scan. So, preview, if we click preview, it has started scanning. It is just a quick scanning or the check of the height of the object. It is not the exact scanning. You can see the preview is happening. It is scanning. So, you can see the scanning is happening. So, this is scanning, the light is rotating, single flash is there. Now, the scanner will read the actual height and diameter of the object and tell us, and we can fix that height. We need not to go up to 406 mm. It will decide the height, we can fix that. So, this is sizing or acquiring the exact size of the scan. This is just a preview that is happening, not the actual scanning. So, when scanning would take place, it will scan the exactly what the preview data has given the input into that. So, this is the rough scanning, the camera is going up and down, camera is here now. It is checking the height of the object, table is rotating here. So, the table is rotating and that is describing the circumferential geometry and camera is detecting the height. So, those things are being defined here. In the screen also it is showing the progress. It has shown that around this much 29% of the scanning in the preview phase has happened. It is showing the progress, so now 41%. Now 43, 45, this preview is happening here. Also we can see one thing, it was showing 406 here, 406 millimeter. Now it is showing 172.6 here, which means the maximum height of this object is 176 and we need to go to 406 mm. So, it will just scan up till this height, the maximum height that it will go. So, it has measured the height of the object up to a single place of decimal. So, here we can see the diameter as well. Diameter is from this is the center line, diameter from -50 to 50, it is less than 100. If 50 comes here, 50 is this line. So, it is also 50, it is around 80 or less than 80 mm dia is there. So, when we go for scan, what will happen? It will just read this dia, only this dia and this height. It would not waste time in reading all this dia and the height up to 406 mm. If we do not go or choose the preview option, it will just scan the whole volume in the chamber. So, let us start the scan. So, we have fixed the height direction as 0.8 and circumferential pitch as 0.9. We have started scan. It is now processing. Now, it is receiving the data, processing, it is receiving the data. We can see that a small red dot would come here. It has started from the bottom and it is trying to getting the slices towards height. So, it is very minute or very small light. With the naked eye, it is because it is the object is having serrations or different profiles here, we cannot just see it all the time, but at some point it will definitely come here. I will try to show you when it comes. It is rotating and light would be around here. Here because the scanning is starting from the bottom towards top. So, light would be somewhere here, it would come. So, it is close to the foot of the object that we are scanning, the foot of the body here. So, it will come around here. Yes, here we just saw the light. This is the red light. This is the red light. If I try to rewind this, yes, here you just saw the red light. It just moved from this point to this point. So, this is the red light here. So, this is the red light that moved from this point to this point. So, this is the scanning that is happening and it has reached up to around 20 mm height from the base, and this is how the scanning is happening. Now, we will scan the whole model because it will take some time. We will scan the whole model and get you the data that is generated on the computer. The scanning is happening, and around 25% scanning has, 26% of scanning has happened. Estimated time is around 19-minute processing time is. So, total job was of around 28 minutes and 19 minutes is left. So, it has received around 27% of data till this point. The scanning is happening. This is showing the progress of the scanning. So, this we have obtained the scanned data and full scanning has happened. You can see the body look like this. So, this is the model with all the noises and all the errors. We haven't cleaned the data. You can see that there are certain noises here, certain noises here. Okay. This is also the unwanted lines. These are the these are noises, okay, or the errors. Here also there are certain errors. So, that would come in this complex object when it has very simple or not just a cylinder. Some errors have come because it could not detect this vacant space behind the hand of the object. It could not detect this. So, we need to work on this. Also here also there is some recession, some material has not come. So, that can be worked easily using different tools here. So, for modifying and rectifying these errors, we save the data in a useful format and go for the modeling, where we work on the patches and surfacing, and we develop the solid surface properly, and we remove all the noises. You can see this view also. These are the colors. Red lines show that some depth or some errors are there. So, some noises are being shown here. So, this is only to show that there are certain noises are there. So, this is the scanned data or point cloud data. So, this is point cloud that is shown here. So, this is point cloud. It is showing the data in the from the points, and the multiple points are being shown up, and you can see because the points are too dense. So, that is why it is showing the complete black. If you can see these points are here, these points have generated. So, what we called the noise that is obtained from these points only, it has developed a solid from these points. So, this is from the point cloud data. We can see the very less dense cloud and remove it from there. So, that can happen very easily. The automatic surface generation has generated this surface here. You can see this surface is generated here. So, it has made it a part of the object which is not there. We can remove these points, we can just select this volume, these dots can be removed and can be worked on. So, these are some unwanted dots. There are certain points where the data might be missing. We need to add some patches there. So, all these need to be worked on. So, the supporting softwares are also there that helps to work on this. This is just the software that is provided by Dr. Pizza 3. So, the name of the company is Ronald. These softwares helps to develop the model for CAM, for computer aided manufacturing, and for 3D printing these can be used directly. So, this is the mesh form of the data. This is data in the mesh form of the object. This is the raw form of the data. When these are the patches, those need to be worked upon. So, this is density. So, these are all pixels in a way. So, these are empty spaces where patches are need to be put on. So, this is the way we have produced the data. So, this is the manual that is provided by the vendor. They have just mentioned the steps that we just saw. We just start the machine, then we click on the scan button, this window opens. We choose the scanning mode, that is either be rotary or plane scanning, and the object whose shape is close to sphere or cylinder can be used in rotary mode. Other objects go in the plane mode. Then we click the preview button to finalize the height and the width or the radii or diameter of the objects. This is the 4 general steps. The 5th step is, while viewing the preview, we need to do following settings. We need to select the scanning pitch. Is the pitch okay or not? We need to finalize this thing. Then we can just scan properly. This we can even specify from 1 to as many as 6 surfaces when we are scanning. It is good idea to decide on the number of surfaces to match the shape of the object. The scanning angle, as we have mentioned, is the angle of the laser for each surface. It may be good idea to set preview to top view. So, before this I like to mention one more thing, effective sensor area. Now, the figure at the right here shows the area in which the machine sensors detect a reflection of the laser beam, allowing the objects to be scanned. Okay. The surfaces reflect that the laser light, as the table rotates and object passes through this area, can be scanned. When scanning an object that is considerably uneven or that is crank shaped, you may need to take this effective sensor area into account. So, this effective sensor area is this here. So, this is the table. So, this is not okay. For effective sensor area, it is not recommended to keep the object at the side. That is why we kept the object at the center here. So, if the object is mounted at the edge of the table, it may not be possible to scan the entire object correctly. So, in this case, the apple shown at the right of the area enclosed by a shaded portion is not scanned. This is not scanned. Okay, this is effective area. Though the table is this big, but this is not scanned. Now, it is showing how does the pitch work in the plane scan and in the rotary scan. In the plane scan, it is kind of a grid. This last point and the start point, this height is the pitch. The minimum pitch is this one. This is the minimum pitch. It is 0.2. This is circumferential pitch. So, this is at what degree does the data gets collected. There are certain things which are not shown in the laboratory. To brief a few of them which are there in the manual here. So, this is how we check the scan results. So, like we showed in the demonstration, we get this scanned result that is known as the object. So, this scanned is known as object. We drag the object to orient the area that we need to examine in front. So, we can select different surfaces. So, this plane indicates the name of the group that contains number of objects. This indicates the name of the object. So, this switches between showing the hiding the group of the objects. We can scan different objects and get them put together into one. So, selecting and scanning a specific area. So, we can scan and rescan and again rescan to select a specific area. So, after the basic scanning, one can select specific areas and perform additional scanning or rescanning. The available types of rescanning are as follows. Number 1 is rescan. We use rescanning when we want to increase the number of measuring points or scan points and enhance the degree of completion of 3D data. Because the pitch is limited, sometimes we need more detail at a specific point. For instance, in this camera, in this scan, this data might be missing. So, we rescan at this area. In this case, this is the coarse scanning, this is fine scanning. Okay, this is coarse and this is fine. So, line scan or point scan. Sometimes we use line scanning and point scanning when we want line segment or point data to serve as supplement data for 3-dimensional modeling operations using CAD and computer graphics programs. So, these can also happen. We perform the line scanning at this specific area and get only this dense area. So, also we perform the point scanning here and we can just have the 4 points here 1, 2, 3, 4. Line scanning is we have just made 1, 2, 3, 4 lines. In between this here the scanning would happen again, and point is we get 1, 2, 3 points, and 3 are the minimum number of points that can help to develop a circle. These 3 points can help us to make a circle and this circle can be scanned like in this case. Okay. In the scanning we take 4 points actually, like in coordinate measuring machine we took the 4 points. In CAD drawing there are 3 points when we draw using any software or AutoCAD. Next is scanning modes for rescanning, scanning using plane scanning, scanning using rotary scanning, plane scan or rescan can happen, rotary rescan can happen. You can go through this manual. This is rotary line scan. Only the line segment shown by the thick line can be scanned. So this rescan or line scan can also happen, rescan and line scan. So when we are rescanning the areas which could not be scanned, so we choose normally plane rescanning. When object has a complex geometry, we can even use the rotary rescanning. So these kind of scannings can be selected accordingly. There are different methods, you can go through this. We can also create new polygons. As I said, patches, this is known as, which is patching, kind of patching. Okay. For instance, if it is missing here, as you saw in the head of the sculpture that we scanned, it was something was missing in the head. So we can generate additional polygons here. You can fill it. That happens using a command called polygon mesh. By a command called polygon mesh. This is the command that helps to add new polygons. So here we have the polygon mesh at the left corner. This is create polygon mesh, and we select the parameters of the polygon mesh, and detailed information of the polygon mesh dialog box opens. If the polygon mesh is not what was intended, we change the parameter and create it again. This is one of the features that can happen. So this is generally what we do. General scanning, we scan, we get the CAD data, that is the point cloud that helps to generate the triangulation mesh. That mesh helps us to get the surface, which then helps us to get the solid modeling. Then we saw the errors in solid modeling and start working on that. How to work on that? Either we can work in this same software that is provided by the vendor, or we can work in some other software that has a better capability and work on them. And there are also automated modes to add patches, etc. But this is just saving data and exporting data. Exporting data can help in DXF and STL format. So as I said, different other softwares can help to work on the scanned model. So it can be exported in these ways, DXF and STL and some other formats as well. The certain editing of the data can be done. We can add patches, we can see different views. These things are the more details that you can get to know if you read more about CAD modeling or 3D scanning. So this was all in the laboratory demonstration on 3D scanning. We haven't worked on the data cleaning and generating the solid model completely. We haven't worked on all the commands because that would have an extensive presentation of maybe 4 or 5 hours. So we have tried to complete just the laboratory demonstration how to operate or work on the machine that is a 3D scanner, which was Dr. Pizza LPX 600 model. And in the previous lecture we saw RTEC 3D space spider scanner, and also we saw the coordinate measuring machine, which is a contact type of 3D measurements. With this, reverse engineering and 3D measurements parts is over. Next we will start with the processes, rapid manufacturing processes. The very first process Professor Ramkumar will discuss is polymerization process. Then we will come up with powder based additive manufacturing or rapid manufacturing processes, that would come in the next week, and a couple of processes would be discussed in the forthcoming weeks. Then I will discuss about rapid manufacturing materials, then post processing concerns, and rapid product development. In rapid product development, we get the CAD data, we try to develop the product rapidly, in which selecting the proper layout for additive manufacturing is also important. Factory simulation can also happen. So these things will be discussed in the course further. So let us meet in the next lecture in the next week. Thank you.